But however, quickly the current will saturate the bulb. Because why? Because the number, the ray of the photoelectron generated by light is fixed, right? It's fixed. Okay, so what's this? The maximum what? Maximum photocurrent for this case. Okay, how about if we reverse? We reverse the voltage, the applied voltage. Reverse means here become negative. So the photoelectron generated by the photoelectric effect will start to feel the force from the reverse voltage, right? So what happened? This is a reverse voltage, right? The photocurrent then will start to decrease, right? And then to a certain reversal for the voltage, the current will start. So what does this mean? Kinetic energy. Right? If this is a E reverse. So kinetic energy E times reverse. Very simple, right? Right. So then Einstein can use this information to understand what kind of metal it has, right? But this is not the reason Einstein get his Nobel Prize. The reason is what? For example, this is so-called low intensity for the light. Low intensity. Remember this. What's the intensity? So he increased the light with higher intensity. So what happened? Higher intensity. So the maximum high is higher than maximum low. And also the saturation, the maximum, right, saturation is higher. But surprisingly, Einstein found the low intensity and the high intensity of the input line, they have the same reverse voltage. That triggered a mystery for Einstein. Why? Because for Newton, okay, they call it Newtonian mechanics, Newtonian mechanics. The higher intensity means the electron will receive more energy, right? Then the energy, more energy, then after I pay off, right? For example, if you are now, because the electronic industry in the Taiwan currently is they doing a very good business. So recently I received a lot of requests for our department, our school. The company will come to our school, our department, say, hey, I provide your student scholarship, maybe 2 years, 3 years, 4 years, right? Every year certain money is a sort of a scholarship. But after your graduation, you need to come to my company to work like the same amount of the time, right? 2 years, 3 years, 4 years, But before that, that's a few years, 10 more years. There's a company, Xinxin I also doing the same thing for them. But even though you receive the scholarship, right, after the graduation, you still have a choice not to work with the company. With what? With the condition you need to pay back. Okay? Pay back the scholarship, the entire scholarship you received for the past few years. So sometimes we call buy-off, right? So means the electron, there's an engagement combined with the atomic nucleus, okay? So I pay the money to the energy to buy off my release. So for Newton, okay, the Newton theory or Newton mechanics, right? The higher intensity means the electron will receive more photocurrent and buy off. Okay, right? Kinetic energy. Then Einstein will expect for the higher intensity should get higher what? First, voltage, because kinetic energy. But he didn't. He found whatever, he just repeat, I change. All come to the same reverse energy. That means what? This finding suggests Newtonian mechanics is not right. So that's another evidence for the quantum theory. So quantum theory is the line is not continuous. Right? Just like Newton expected. Right? It's a quantum. So all the line is quantized. They are a portion, just a portion of energy. Okay, you know what I mean. So the higher intensity is a higher density of the light quantum. Means the per second more photon. Okay? More photon. Photon is the quantized light. Okay? Quantized. They are not continuous. They are continuous. So means that's why we say it's fixed. So when your wavelength is fixed, the energy for the quantized light means photon. They are the same energy for each photon. So the higher intensity means the per second the per second of the photon is higher. Right? But that means the electrons in the metal, they receive the photon with the same energy, regardless what intensity of the light you input. 听懂意思？你一大堆人冲进去，跟比较少人冲进去，每一个人的分量的 energy 是一样的。所以so the electron receive the same amount energy of the photon, regardless the intensity. So here's what I said. Same for what? Same for different intensity. So your kinetic your kinetic energy of the photoelectron will be the same. That's why he got the Nobel Prize. Okay? That's overthrown the Newtonian concept. The energy is continuous for the light. Yeah, quantized light is different. All right? So this is famous. So if you know this, 你知道这个，但是可以差很多了。All right. Okay, that's it. Any question? 什么问题？听懂吗？听懂？确定？这个灯分享，前面这个。这个是这边才关。好。That's better, right? So today we're gonna talk about this. Okay? I borrowed it from the City University. The X-ray photoelectron spectroscopy. Okay? Spectroscopy means we use the spectrum from. 下一个。Okay? Photoelectric effect. Now you understand. Right? So, it's number 1721, 1921, Einstein get a Nobel Prize. And how many years later? 60, okay, I'm quite close. 60 years later, this guy can't get a prize. We use the photo emission as a light in the light photon. Right? Okay? So, the X-ray photon is mu provide the energy for the core level. Okay, core level. Why core level? The information from the core level is more what? Is more informative. The core level. KLM. Core level. The higher level, the information is less, or it's difficult to resolve with lower resolution 解析度。OK， 下一个。OK， so XPS as long as SCAR, okay, XPS. SCAR, the major difference is SCAR, they equip the XPS, because the X-ray only can be absorbed in certain depth, very surface, right? Because X-ray, if the X-ray cannot penetrate, deep enough. So that's a good thing, We can use XPS to understand the very, very surface structure or the chemical situation. All right, but for the S-CAR, we have the argon ions bombard the surface. So XPS, then we have another beam, argon beam, to